Now, coming to the boiling point, just to ensure that you know the definition of it, the temperature at which a liquid boils and turns into vapor at atmospheric pressure is very, very important, is called the boiling point. Because the pressure, the change in pressure actually plays a role, it is a very vital role in increasing or decreasing the boiling point, which you will understand in higher grades. So प्रेशर चेंज होने से बॉइलिंग और मेल्टिंग पॉइंट या फ्रीजिंग पॉइंट के ऊपर असर पड़ता है, इसलिए वी हैव स्पेसिफाइड एट एटमॉस्फेरिक प्रेशर. एटमॉस्फेरिक प्रेशर एट सी लेवल is again, as I have told you earlier, I'm repeating it, is 1 atm, where atm is another unit of pressure. We have till now learned that Pascal is the SI unit of pressure, but another unit of pressure is atm. This is the atmospheric pressure. So at sea level, the atmospheric pressure's value is exactly 1 atm. The higher you go, the more altitude you take, the higher you go in terms of the altitude, the atmospheric pressure decreases. Atmospheric pressure decreases on high altitudes. The greater you go in the depths of the seas and oceans, the atmospheric pressure increases. And therefore at sea level is where I say the temperature is 1 atm. So it is very vital to keep in mind that the pressure should be the atmospheric pressure, and therefore the melting and boiling points vary at the atmospheric pressure. Now when the temperature keeps on getting increased, the molecule becomes so and so violent, as we have seen, that the particles move far and far away, farther and farther away from each other, thereby converting from liquid into vapor state. Now, boiling, although takes place when plenty of heat has been supplied, specifically the boiling only takes place at the boiling point, but we have also seen water vanish. So if it rains, you see that after a couple of days, the water which was stagnant on the roads or on the pavements vanishes after a couple of days. This is because even though the temperature has not reached 100 degrees Celsius yet, the water vanishes. The water has not boiled, in fact, it has evaporated. So evaporation is that phenomenon in which the state of a liquid substance, that means any liquid, changes into vapor state even when the temperature has not reached the boiling point. So evaporation can take place at temperatures lesser than boiling point, can occur at temperatures lesser than the boiling point of that liquid. BPT stands for boiling point. So अगर कोई लिक्विड का बॉइलिंग पॉइंट 110 डिग्री सेल्सियस है फॉर एग्जांपल, सो इवेपोरेशन ज़रूरी नहीं है कि 110 डिग्री सेल्सियस पर हो. बॉइलिंग विल टेक प्लेस एट 110 डिग्री सेल्सियस, बट इवेपोरेशन कैन टेक प्लेस एट टेम्परेचर्स way below that, right? So coming on now to the gaseous state, we have learned कि solid state में there is fixed shape and fixed volume, right? Liquid state में there is no fixed shape but there is a fixed volume. Coming to the gaseous state, what do you think would be the situation when it comes to the state of volume and the shape? क्या होती होगी gaseous state में volume और shape की properties? Would they be same? Would they be different? What do you feel? So I'll just summarize it here. In the meantime, you think, take 10 seconds. In that 10 seconds, I'll be able to summarize the points. So, as we discussed in case of solids, shape and volume are fixed. In case of liquid, the volume is fixed. It is definite, whereas in case of liquid, the shape is indefinite. That is, there is no defined shape. When it comes to gases, supposedly, if I take an oxygen cylinder filled with oxygen to its brim, right? The volume of this oxygen cylinder, let's assume, is 1 liter. Now, if I start releasing the oxygen from its tank through a nozzle, if I start releasing oxygen through its tank from this tank through a nozzle into a room completely closed, now what will I find? I will find that all the oxygen has spread across this room in different directions. And this oxygen gas will now acquire the shape of this room and the volume of this room. So gases occupy the shape and volume of the container that they are stored in. They do not have either a fixed shape or a fixed volume. राइट सो जब ऑक्सीजन सिलेंडर के अंदर ऑक्सीजन स्टोर्ड थी तो वो 1 लीटर का वॉल्यूम ऑक्यूपाई कर रही थी और इस कंटेनर की शेप ऑक्यूपाई कर रही थी. लेकिन जैसे ही मैंने ऑक्सीजन गैस रिलीज की, उसने क्या किया, उसने इस रूम का वॉल्यूम ऑक्यूपाई किया पूरा, बिकॉज वो पूरी की पूरी स्प्रेड हो गई. उसने इस रूम का वॉल्यूम ऑक्यूपाई कर लिया, विच लेट अस अज्यूम इज 10,000 लीटर. उसने पूरा रूम का वॉल्यूम ऑक्यूपाई किया और शेप जो पहले उसने सिलेंड्रिकल वेसल की शेप ले रखी थी, नाउ इट हैज ऑक्यूपाइड द स्पेस ऑफ दिस, लेट्स से अ क्यूबॉइडल रूम. राइट, सो ना तो उनकी शेप पक्की होती है, फिक्स्ड होती है, ना ही उनकी वॉल्यूम फिक्स्ड होती है. उनकी किसकी? गैसेस की. राइट, एंड लेट्स see this again through the simulation. Again, moving randomly back to the simulation, I keep on increasing the temperature, I keep on changing the shape, the volume will reduce, the shape will also change. So if I reduce the temperature drastically, you can see temperature say the only aspect of bringing temperature here is to show you that temperature also affects the packing of any state of matter. So when I reduce the temperature, the energy gets reduced, the heat gets reduced, which drastically brings down the randomness in the system, and it brings the particles more at, compared to the previous state, more at rest. Not at complete rest, but compared to the previous state, more at rest. As it can be seen here, जैसे ही temperature is about 50 degrees Celsius approximately, you can see that the particles have started to settle down. So this is all about the gaseous state. Now it has been explained in the book again with the help of a couple of activities. In first case, they have taken this cylindrical jar, and in this cylindrical jar they have lit an incense stick, and all the incense या जितना भी smoke है of this incense stick is being discharged into the cylindrical jar, and a glass plate has been used to cover the top of it. All the smoke gets collected inside the jar. On adding another cylindrical jar on top of it, initially you find that there is no smoke in the cylindrical jar B, the gas jar B. But धीरे धीरे with time, all the smoke from cylinder A or glass jar A passes into gas jar B, and both the jars have now the smoke of the incense stick. It means the volume of the gases are never constant. They occupy the volume and the shape of the container that they are stored in. Another example is being given using iodine. Iodine ki vapors are violet in color. So you will be able to very easily see the change in color by adding the gas jars on top of each other. So in the first stage we have iodine, single gas jar mein placed hai. Now I have the fumes of iodine inside this gas jar, and I very slowly and carefully add on another gas jar on top of the first one. So let's name this A. This is A. This is again A. This is B. This is B. जैसे ही मैंने गैस जार B रखा गैस जार A के ऊपर, I find that all the vapors of iodine are gradually moving from A to B, and after some time I'll find the fumes of iodine, the violet fumes of iodine, have completely engulfed both A and B. That means the volume of gases is never constant, they keep on flowing. and therefore very importantly it is to be noted that both gases and liquids, since they can flow, they both are collectively called as fluids. I repeat, since both gases and liquids can flow, they both can flow. पानी भी बहता है, हवा भी बहती है. They both can flow, therefore they are both called as fluids. Right? With this small topic of the different states of matter is covered. We've covered the solid state, the liquid state, and the gaseous state. We'll discuss the remaining topics in the next video in detail. Again, not mincing with the time and not mincing with the detailing of the concepts at all. While the understanding and explanation part may take a little longer, but it is for overall conceptual building of each one of you who watches the video, just to make you understand the concepts right from the very basics of them, and then building upon them gradually and steadily. So please ensure that you understand what is being told in the video very clearly, such that these concepts, when you reach grade 9th, will be repeated again with some more added concepts onto it. You find it easier for you to understand them when you reach the higher grades. So thank you for your time. I'll see you in the next video, and keep shining, keep learning, and keep having a drive in yourself. Thank you.